This conference will now be recorded.
Okay, and thank you to Jonathan Bray who invited me to this talk. Thank you very much. I'm currently the regional principal engineer at Eastern. So yeah, so it's the largest region in Network Rail. I was previously the head of track engineering at HS1 for 3 years. So today I'm presenting the challenges of maintaining a high-speed railway from my experience at High Speed 1. So, okay, let me just see. So summary of the track asset. So the track asset is about 109.5 kilometers long. It's a 2-track railway, and we have 154 units of SMC, of which 62 of them are swing noses, and we have 19 sets of expansion devices. Okay, so we have 2 sections, section 1, which opened in 2003, and section 2, which opened in 2007. So that means the railway is about 17 years old now. So it's past its midlife, if you like, for railway terms. I mean the track asset, that is. So we have a little bit of SNC in St. Pancras, which is British made. Those are the low-speed SNCs. And then we have a little section of track and Eurotunnel asset, which is also British design for now. Okay, so we have a land speed record that was set in, I think, 2003. Do you know anything about it? Do you know what the speed was? I think previous to that speed was the Mallard, wasn't it, in 1938, when we set the speed for 125 miles per hour. So in 2003, the land speed, railway land speed was 2008, I mean, not 2008, 208 miles per hour. And that's around Waterloo, the Waterloo Junction, I think the Falcon Junction way, where it's quite straight. So a little bit about HS1 and Network Rail High Speed. So a lot of people doesn't know that Network Rail High Speed is contracted to operate and maintain and renew the infrastructure. So we are like the infrastructure manager, but our client is HS1 Limited, who has 30 years of concession to own and operate HS1. So we also maintain 3 stations, St. Pancras Station, Stratford Station, and Epsom Station. So the track system is designed for high-speed international trains for up to 300 kilometers per hour, and that's the Eurostar Class 373s and Class 374s. And then domestic trains, the Southeastern Class 395 Javelins, they go at 225 kilometers per hour. So in old money, that's 140 miles per hour. And then we have freight trains as well, which is increasingly more now during the COVID lockdown. So pre-COVID traffic, we have around 8 to 20 mega gross ton per annum. Okay, sorry. So HS1 Reference System. So HS1 is French built. It's based on SNCF TGV Mediterranean. So the same design as SNCF track. So everything is French. As I said, section 1 is 300 kilometers per hour and section 2 is 230 kilometers per hour. So both sections we can carry 22.5 ton axle load. And we have a track center line spacing of 4.5 meters in section 1 because the speed is higher. And the track is UIC GC gauge, if you like, so it's a European gauge. And we have slab track section in section 2, about 40 kilometers of slab track. So we're talking about French assets. So we have swing nose crossings, we have British design crossings, British design crossing, and we have 2 units of hybrid British and French design installed last year in February. So the 32 units of British designs, they're all RT60 HPSS, and those are at St. Pancras. And then dotted along the main lines, are the French Vossel Cogifer swing noses. So we have 99 units of it, of which 62 of them are swing noses. So you can see we only have 6 different sizes of swing nose dotted on the route. So the smallest is 1 in 12, with the longest 1 in 46. So a little bit more about the 1 in 46 swing noses. So we have about 33 units of it. There's quite a lot of them. So they are separated like about 15 kilometers each because they're like perturbation crossovers. So the turnout speed is 160 kilometers per hour. And the toe to heel length is 43 meters. So because of this length, we are having some problems with like trying to renew them because we are trying to source plant that can lift 43 meter of ironwork. And then the tip-to-tip dimension is 300 meters long. Okay, so it uses nublar fastening and all are installed on straight track. So we talked about the 2 hybrid British and French design at Folkestone. So this is when it's in a yard in Vossloh. It has this French POE called the MCM 91, but it combines with the British Ironwork, which is the NR60 Mark II. So HS1 being a separate entity to Network Rail, we are able to design something and then approve it through our SRP, which is the System Review Panel. So this hybrid was designed by Vossloh, tested, integration tested, and then approved by SRP for installation last year. So why do we want to use the MCM POE? The reason is the performance. The mean time between service affecting failure of these MCM 91 points at the moment, it's 40 years. So why not? So the track performance over the 17 years, as you can see, it's quite good. It's I think we only have 47 service affecting failures since commissioning since 2003, which is very good. So there's some years that we never had any failures. So 2019-20, which is last year, we only had 2 failures, resulting in 200 delay minutes. So as you can see, it's very obvious that in 2018 and 19, we had a sudden surge of faults. We had 9 faults. Those include like crack crossings, cracked fish plate. So it's sort of like changed the course of the organization, if you like. So I'll talk about it in the later stage. So at the moment, you can see the construction and the maintenance tolerances. What's the difference between high speed and conventional? So you can see that the construction, which is in black, and the maintenance tolerances, which is in green. So as an example, the 3 meter twist for Network Rail, the highest speed bracket, the construction standard is 6 millimeters, whereas in HS1, it's 3 millimeters. So for Network Rail, 15 millimeters is an actionable fault. HS1, 7 millimeters is an actionable fault. So for high-speed traveling, tolerance is key. Okay. So the concept of maintenance at high speed on high speed is predictive maintenance, preventative maintenance, and corrective maintenance. It's the same everywhere, I guess. But the thing is that we focus more on predictive and preventative maintenance because we believe that good predictive and preventative maintenance will result in less cost from corrective maintenance. So just a reminder that all maintenance activities at HS1 are green zone, including inspection. So this is the FNC inspections that we do. For high speed, we do 5 weekly basic visual checks. 6 monthly detailed component, 12 monthly detailed component check and tightening of the fastenings. Same tankers, it's more stringent because of the tight radius and higher wear rate. So as you can see on the photograph, this is the smallest swing nose that we have, 1 in 12 swing nose at Stratford International. Okay, so typical plain line on high-speed one are these twin block sleepers. So these twin block sleepers are a French type design, but they're going out of favor at the moment. So we have why? Because of cost, as well as because they tend to twist on highly canted track. So for us, our highest cant is 160 millimeters. So these tend to twist a bit, so it's more maintenance. So anyway, so we have 6 weekly same tankers plain line and 10 weekly Alumicart inspection or on foot on the plain line. So why do we use the Alumicart? You can see on the bottom photograph, that's the Alumicart. And then the second picture shows what it looks like when you're doing the inspection. And then the third picture at the bottom shows the long tunnels, because some of the tunnels are 10-kilometer long. So to do it in one go, you can't walk it. So we have to use this Alumicart, which takes about 1.5 hours to get through the tunnel. And then if you look at the bottom right photo, that's a rail. So that's what we use to measure the welds. You know, for high-speed rail, we need a very, very smooth finish on the weld. So the tolerance is plus minus 0.2 for the weld. So we use this rail to measure it. And then if it's high, we will grind it. If it's higher than 0.2, meaning 0.3 and above, we will have to grind it. Otherwise, we'll have voiding problems. Okay, so dynamic inspection. So we have track recording vehicles. We make use of Network Rail's track recording coaches. So they come to us every 6 weeks on the main line, 12 weekly on the crossovers, and also on the loops, and then 26 weekly at the interface areas, such as the Waterloo line and KL line. And then we have UTU 16 weekly, cab rides as well. And we have line side asset inspections under traffic in the daytime. So we use this software called Irises to analyze, predict, and report. So we use it to predict when the peak of the twist, for example, will grow to a certain height. So we intervene before it gets to that value. So this is called predict. This is how we predict and prevent. So occasionally, the TRV is not reliable. We have this UGMS module that is fitted on our MPV. So we use that to supplement missed runs or loss of data from the TRV. Okay. So yeah, so at the bottom, those graphs are like our track quality reporting that we produce after each run. So special features considerations at HS1. These are examples of the features that are challenging to us. For example, the tight curves that I mentioned before, they're highly canted. They're canted at 160 millimeters. So to maintain the cant is a challenge. The long expansion switches, as you can see, that's the Thurrock viaduct expansion switches. They're quite difficult to maintain because of voiding and change in profiles. So we have loads of voiding issues and wear issues as well. So we do have a plan to renew these now. And ballast and slab transition. So as you can see in the middle drawing, is our slab track and ballasted track transition. This is a problem site. And then from learnings from all these installations, SNCF has learned that putting in ballast mat as well as under sleeper pad is not a good idea. because it means that they're crushing the ballast between them even more. So they have come out with a new design, but we have to live with this old design. So if you can look at the photo on the right, you can see white patches. Those are the under track crossings. So we try to dig out some of the sleepers at where the under track crossings are, or the transition from monoblock to twin block. You can see the condition of the sleeper is quite poor. So we have to start changing the sleepers at these sites because the track geometry is not holding up. Okay. So if you have a problem with my sound, let me know. Okay. Thanks. So for the next slide. The next slide is about hot weather. We do have hot weather problem as well, but over the past few years, thanks to all the preparation, we didn't have to put on any speeds. So we didn't have any speeds when we had the record temperature of what 38.6 degrees at Cambridge and all that. Talking to our counterpart in SNCF and Infobel, they didn't put any speed on as well when the temperature was above 40 in France or in Belgium. I think they suffered from OLE problems instead of track problems. So for us, we have reinforced ballast profile. So the ballast profile is about 500 mil wide, but for a reinforced one, we have about 100 mil thicker, as you can see at the shoulder. So it's about 450, 500 mil wide. At low speed lines, and you can see these funny little joints there. They're called ground permissive joints. I was surprised to see them when I first started because the gaps were so big, but it turned out to be sort of like an expansion joint, if you like. So they're used in place where we can't put adjustment switches on, or use on viaducts as well, such as the Temple Mills cord. So these joints, they have the bolts are 18 millimeters, whereas the holes are 23 millimeters. So it allows about 5 millimeters of movement in itself. So I think these are unique to HS1 because I haven't seen them in Network Rail. Okay, so that's the other feature. And of course, the tunnels. We have the twin bore tunnels. They're all slab track. So we have them, London Tunnel 1, which is from St. Pancras to Stratford, and London Tunnel 2 from Stratford all the way to Ripple Lane and beyond. Okay, almost that three. So, well, to Wennington, sorry, to Wennington. So they are 8-meter diameter. So as you can see on the top photo, we have problems with it. We have corrosion problems. So one of the failures, the 9 failures that we had in 2018 was a section of rail with longitudinal crack. So we had to block the line and remove the rail. So you can see the big photo, that's the tunnel. If you look closely, you can see it's wet on the ground. So yes, so we have water leakage along bits of parts of the tunnel. I think we had a big gout failure a year ago or something. That's part of civils, I think. So we are remediating these problems as well. Okay. So another problem site for us is the ETML box, the East Coast Main Line box. It is a floating track slab design. So it's concrete slab on a resilient bottom. So as you can see, all the ironwork, the switches and crossings are cast onto the concrete. So, but this, the design, we can't see any resilience layer between.
I'll get the dinner going. I've got to warm the oven up first. It's not ready for this lot. Yeah. So I'll get that going, and then I'll get the organised, get it in, and then it's going to be about 25.
Sorry, it's Quentin talking. Okay, sorry. So yes, so there's no resilient layer between the ironwork and the slab track, except for the pad. But as Mark or Callan, I see him on the call, they'll tell you that those pads are like sort of like casted into the in the concrete, so it's not providing the resilience it should be. So at the moment we are having issues with screws, as you can see on the photo on the right, screws breaking and coming off. So we have now engaged with the expert Robert Thurser to help remove and put in new screws. Okay, so we have other common track defects, the network. We have RCF problems. As you can see, we have corrosion problems. We have switch rail damage problem. And the one unique one is ice pitting problem. So 2 years ago, we had the Beast of the East. It's almost 3 years now. It was 2018. So it was very, very cold. So when the water comes down, it immediately freezes on the railhead. So it's like a little ice bubble on the railhead. And then the train, high-speed train, then run through it and then just hammers the ice into the rail. So we have all these pitting that looks like ballast pitting, but are not ballast pitting because the edges are quite smooth. So it's not like rough edges on the pitting. So those are called, we call them ice pitting. So we had problems with that. So after that Beast of the East experience, we had to grind the rails, significantly reducing the life of the rail. I think we had to grind about 0.8 mil to get rid of some of the pittings. Okay, so these are other common defects. So we have adjustment switch, a breakout, the cracked fish plates. I think we had up to now 4 cracked fish plates, I think, or more. And then we had 2 crack crossings. That was the first in our route in 2018. So this one was at the ETML Box. So you can see that's the casting foot crack. That's quite common in network rail. So it initiates from the little pocket at the foot. So we had to emergency change the crossing. Okay, so and I think it took 6 hours to get this crossing in. So the main maintenance activities in high-speed line is temping and grinding. So our maintenance access is 4 hours weeknight, 6 hours Saturday night, and Friday night is called trace free, which we run track recording trains or test trains. So for maintenance temping, we have one major campaign each year. So usually it's springtime, but last year we changed it to September. Springtime is because it's not warm, so it's and it's not too cold, so it's a good time to temp. We changed it to September because there were a few April when it did go too warm, so we thought September would be good. But I think we're changing back to April again. So we do sprinter temping as well. So sprinter temping is like localized fault. For example, less than 40 meters fault. So we don't want to send in a big temper to just temp out localized fault, because temping does severely reduce the life of the ballast. So all our temping includes DCS. So we do dynamic track stabilization, and then they're all tamped to a known position. So it's all TAD, which is true alignment design. And we monitor the work throughout. We have survey before and also after using the train as a handback criteria. Okay. So as I said, grinding is very, very important to us. We do it on our annual grinding campaign. So it's critical to manage the conicity for high-speed line, for acoustic purposes, and for ride comfort at high speed. So I don't know if you remember, like 2010, we had all these news about wobbly trains and all that, the javelin. So maintaining chronicity is key for high-speed line. So we did some reactive grinding when the railhead is damaged by ice during the winter time. So we use 24 stones grinding machine for S&C, and these are all our European suppliers. So this is Spino from Austria, and 48 stones for plain line. So we grind our rails all to 1060E2 profile. Original installation was 1060E1 because that's part of that that program to change to resolve the chronicity problem with Javelin train. We ground the whole route to 1060E2 profile. So during the last 3 years, we found out that some of our switch rails were actually sitting higher than the stock rail, the one stock rail. So you can see the little mini prof measurement on the bottom left. You can see that the switch rail is higher. So in this case, the switch rail is about 3 millimeter higher, but we did find switch rails that were 5 millimeter higher. So this is because of the through route being used more than the crossover, perturbation crossover. So this is a common occurrence in Europe, but we only found out like 2 years ago that this is an issue. So what is the importance of this? During cab ride, sometimes you'll feel a bit of a like lurch when the train goes past switches, and this could be the reason because the contact is changing from the switch rail to the stock rail. So and it also has other issues, like for example, we have broken roller plates quite a lot, but it might be that the wheel is sitting on the switch rail, which is sitting on the roller plate, that cracked the little corner on the roller plate. So it might have caused some issues that we didn't know, but we had to correct this. So we had a campaign with Spino Trains, grinding team. So what we did was that we jack up the switch rail. So you can see all these shims on the laid out on the sleepers. So we sort of jack the rail up, the switch rail up, and then put the shims on. The shims are about 4 mil, 6 millimeters to 8 millimeters. So it's gradual. So if you put like a few 4s and 6, and then the 8s on the key point, which is always the 24th bearer of the switch of a 1 in 46. So that's a reference point when the switch rail is of a certain thickness. So yeah, so we jack it up, and then we use the grinding train to go past. And the first campaign, we did about 9 passes, you know, for one switch. And then we were horrified when the switch turned a bit blue, you know, then we had to stop because too much grinding heated up the switch too much. So it turned blue. So we stopped the grinding process. We managed to take off 3 millimeters from that switch, which was a success. So, and you can see from the bottom photo, that's the swing nose. So we managed to grind the swing nose as well for the first time 2 years ago, because before that, we never did grind the swing nose. Okay. So NRHS is evolving. So 3 years ago when I joined, after that, because of all these failures, NRHS started reorganizing. So the whole company reorganized, the track department reorganized. Then we came up with a new track renewal strategy that was developed in 2018. So of course, maintenance strategy has to be evolved as well to integrate with the renewals plan. And we reviewed the standards. The previous version was 2012. So we reviewed it, updated it with lessons learned from SNCF, Infobel, and Spanish high-speed line. So that was 4 of the 5 were published last year, and 1 Matt Rippon is still working on. Good luck, Matt. And also we review competencies as well. We sent a lot of the team for the trainings in Network Rail, because they're used to a good condition infrastructure, but the infrastructure is aging now, so we need to be able to pick up precursors before it failed. And we were doing a lot of we are still doing a lot of plant and new product approvals, because before that we couldn't do, like, for example, like C21 grinding and all these were not approved, so we can't do emergency grinding, etc., etc. And then we adopt a lot of new technologies to improve maintenance efficiency. So this photograph is the last workshop that we had with Infobel, the Belgium high-speed line, and with SNCF. That was in February last year. So we have a very good close relationship with SNCF and Infobel. In fact, we had like 8 workshops with them last year. So that was very, very productive. Okay. So the next one is our track renewal strategy. So it's based on our current asset condition and also HS1's asset management objectives. So HS1 asset management objectives, one of it is that the train delay for each train should not be more than 7 seconds. So based on that, we need to be prioritizing our renewals, make sure we maintain that. So we also need to phase the delivery to minimize service disruption, because being a private railway, we can't say do a blockade, shut the track for 52 hours or 54 hours. That doesn't work on a private railway. Train has to run all the time. So when we did the crossover renewals at Folkestone, it was adjacent line open, or any line open if you like, ALO. So we can't have blockades in high-speed one. So the planning is very vital. So we have 9 projects in flight. We're installing new wraps to facilitate renewals. I think currently we only have 5 access points, which is not enough, because sometimes at critical site it takes 3 hours to get to that site, which is not enough. So we need new wraps. And we're also installing under sleeper pads to retard track geometry degradation. We had a successful trial at one of the UTX site. We put 8 sleepers with under sleeper pad, and we didn't need to temp for 5 years now. So it was very good. We were temping it 2 or 3 times a year, but now we haven't temped it. So we have a run rate of 3 switches a year, route wide to renew the switches. And the biggest project for this control period is actually ballast refurbishment, or we call it renewals or cleaning. That's about 30 kilometers of track. And then we are changing 6 crossings a year route wide. We are re-railing 10 kilometers of track at section 1. That's after the ballast cleaning. And then we're re-railing 3 kilometers of rail at St. Pancras, replacing 9 insulated block joints at St. Pancras per year. Also renewing all the expansion joints. As I said, we have 19 of them, and we're going to renew them all in this control period. So if you look at the top graph, it shows the condition of crossings. So these crossings, based on conditions. So for example, the first crossing 2362, it has over 20 well repairs and it subsequently cracked. So using it as a baseline, we're starting to renew some of these crossings that have the most well repair. So the photos below are just showing some of the work that we have done over the past 2 years. So the bottom small one is the switch replacement at the ETML box on the slab track. And then the bigger picture there is the replacement of the 2051 swing nose at Stratford. So that's our first ever swing nose replacement due to condition. So over the years, we did replace 3 swing noses due to run through, but this one was replaced because of the condition. Okay, so we have this 40-year track renewal plan, as I said, based on condition. So this one, for example, for SNC, you have low speed SNC, you have the original design life that was predicted by the manufacturer, but from our experience, we might revise that. So there's a lot of debate about design life. Okay, so what does design life mean? So does design life means that it will last to 20 years and then you start renewing it, or it will fail in 20 years and then you have to renew it before 20 years? So SNCF's point of view is it's the end of life. So for example, if the high-speed SNC original design life is 25 years, what SNCF do is that they change everything before the 25 year. So it is very expensive in their way of working on that. So so for us, we found out that St. Pancras original design life was 20 years, but actually it's more like 10 years to us. So that's why we started accelerating the renewal of the FNC at St. Pancras. Those are the RT60. So from Network Rail's experience, 20 years is not likely. Okay, so so this is the track renewal plan for SNC. So if we have 143 SNC, so you break it down to how many you can renew per year, you know, so then that's the run rate. So you make it deliverable, you know, so you can phase it and you can deliver them. Okay, so that's how we came up with the track renewal plan. So ballast mid-life refurbishment. So this is a big project. So I highlighted 3 of the projects because those are for with contractors. We cannot deliver them in-house. So we have to find the correct contractors. So to replace 30 kilometers of ballast at the worst affected location. So we can see that we are replacing it around the North Downs Lennon bit of it. So this is the ballast refurbishment timeline that has been produced by the project team. So now we are currently in CP3, that's high-speed CP control period 3. So we start control period 3 2020. So in year 2 we should be around there and so on. So that's the plan. So we have challenges for this as well. The main challenges are there's no in-house delivery capacity. So we have spoken to the high output ballast cleaning team. They have no capacity to deliver this. So we are now engaging with continental suppliers. So we need to make sure that they have experienced staff and they have correct plant. And we have to make sure that materials are available because we use high specification ballast. We don't use the ones from Network Rail. It has to be high specification with a LA coefficient of less than 14, which is very, very hard. Okay, so and then we need approval of the plant as well. So as I said, we need to approve any plant that's on our network to ensure the signaling system is compatible, the gauging is compatible, etc. And access, as I said, we have problems with access as well. We are discussing with the TOC and the FOX on the disruptive possessions. As I said, we have to keep running trains, and then we'll have speed restriction after work. So it's a massive undertaking. And then we're looking at maybe utilizing the Sevington's sidings in Kent as our base. Okay, so to help us with our maintenance efficiency, we have quite a few research initiatives. So I'm just introducing 2 here. So the first one is the ride monitoring system. This is a little box that we use when we do cab rides. So we are looking at, so it measures the acceleration, so you can see where the ride comfort is red. So if you look at the Google map there, where it's red, it means ride comfort is poor, so we can go in and temp it and improve the track geometry. So we are trying to install a semi-permanent one. So this one still needs people to be on the train, but we want a semi-permanent one because now with the COVID situation, we can't do international cab rides. So we are working with Eurostar to put a semi-permanent one so we can monitor the track condition without sending anyone there. So it's in progress. So the other big project is the Techbed investigation method using non-intrusive endoscope investigations. So this is like hammering a little tube which is about 15 millimeters wide and then put a CCTV camera in. You can go all the way down to 1.5 meter deep beyond the subgrade. So you can see what the condition is. So we had a demonstration last year in September, and it was very, very successful. So we have Network Rail Eastern Region representatives there as well. So it's proving to be very successful. So we don't have to dig trial holes like you see on the right of this photo. So and it gives you a cone resistance reading as well. So as you hammer in the rod, if the resistance is high, that means it's very hard. So we're trying to link the resistance to what is it in the track. Okay, so this is just a little video of what you see from the CCTV. So these are a slightly rounded ballast. Okay, so as you go further down, this is actually at HS1. So you can see quite rounded ballast. And then you can see the foul things, fine. Okay, so it's going down like 500 millimeters deep now. So you can see fines starting to form. Yes. So all these are fines now. So you can see that it's quite bad at 600 millimeters and so on. So we are investigating whether it's coming from the bottom or coming from the top. So this is very useful. It takes only 15 minutes to do the work, and we found that it's about only 60% of the cost of using traditional Techbed like trowel holes. So we're very pleased with that. So save us a lot of money as well. So that's all from my presentation, and thank you for staying with me for the 45 minutes. Thank you. So I can't see the chat, so I'll let the chair do the question and answers session.
I'll go through the questions. Got a question from Rufus. He says, thanks Dr. Simpson for your presentation. Please, I'd like to ask you if you've had any challenges with subgrade material deformations, and if yes, what were the condition survey methods used and how did you maintain them?
So well, we are very fortunate that HS1 was built properly with all these proper ground work and all that. So when we were looking at the ground condition, it was quite hard. I mean, we couldn't hammer down the tube any further down the subgrade because it was all very hard. So we have very good ground condition. I think we only had some problems with clay at some London, near London site, but otherwise we don't have subgrade problems.
Okay. I've also got a question from Philip Ransom. He's asking, as HS1 has both freight and high-speed traffic, and a certain amount of high-speed freight, and this is obviously different to high-speed lines, has this made any differences, or have you seen any impacts from that?
Yes, we do have freight trains, which is different to SNCF, but they're not many. I mean, we had one train a day, freight train, but we're increasing the number of trains now. So we now have like trains from Spain directly to Barking, you know, Tesco trains we call them. So, but we still don't have many. But we have two wild system, if you know, wheel impact loading detector. We had stopped quite a few freight trains because of their dodgy wheels. So yes, we use that to monitor the freight.
Okay. With this being a recently built railway, how do you find the quality of the records from construction?
That's a very good question. So all the records, because there's so many, they're put in, well, they're owned by HS1. So HS1 has all the documents and it's stored in, is it ProjectWise? Yeah. So yes, it's very difficult to find the documents because sometimes documents only have numbers. So you don't know what's in the document unless you open it. So yes, my advice to HS2 is make sure you get your document control set up properly.
Okay. Another one from me I got is, notice you said that obviously your railway shuts down at night. Is that something that should happen on railways generally? and giving yourselves obviously a maintenance period.
Yes, I think it's a good idea. I mean, I think especially now that we have this COVID condition, because the access, like for example, in Network Rail has been eroded over the years. I think using this opportunity, we should negotiate a bigger access. I think this is what the Japanese are doing as well at the moment, because of they're running fewer trains. So they're negotiating with the train operators to have a bigger window for access for maintenance.
Okay, I've got one from Stuart. Corey, with what you've learned now for best practice, is there something less practice in locating in the actual position for locating expansion switches so you can increase life?
Locating expansion switches. When you say expansion switches, I take it as the structural expansion joints.
I assume it's something like that. Is there some art to positioning them, I guess, to make sure they last longer?
No, I don't think so. I think they're evolving. Okay, so we have the older design of expansion switches, which comes with the viaduct. So the civil side, I think SNCF has come up with newer design. So when they expand, the ballast don't fall down, you know, and then changes the track geometry. So as we learn from it, designs are being improved, so that we have better designs probably for HS2.
Okay, one from Matt Draper. What is the maintenance inspection regime for the Pandrol Vanguards at St Pancras platforms, and have components been replaced there?
No, so the Vanguard ones at Slab track, yes, at St Pancras station. I think it's just normal regime that we have, like we BVI every 2 weekly. I think because it's on a viaduct, if you know it's on a viaduct, it does expand. So it's a special design that allows expansion and contraction. It's all CWR, but it has expansion and contraction design in it. But I don't know much about it. Yeah.
Okay. Got a question from John Parker. He says, having maintained ballasted and slab track high-speed railway, do you have any views on which one's best for future high-speed lines?
Definitely slab track. You know, for our slab track section, 17 years, we didn't do much, but we're starting to look at the pack we're checking the path in the slab track. But before that, we just did BVI, did nothing to it. So now I think there's a program to remove a few pads, just test the stiffness to make sure they're still working.
Okay, probably I've got a final one for me. Is I was once told by one of the people who was involved in building the HS1 that it's a very French railway. Do you think that this changes any of your practices in any way?
Changes any practice? I think a lot of people who build HS1 is now in HS2, so that's like HS1 Mark II. Okay, but yeah, I think it's good. So there's things that we learn, like for example, the grout plug that came off that caused a bit of a flooding in London Tunnel 2 and all that. So things, yeah, we learn from these design issues, and then we improve on them for future designs.
Right. I've got a question for you. It says, what lessons have you learned that can be transferred to a 200 km/h line like the East Coast Main Line?
Yes, I think, yeah, I think, I'm not sure. I mean, the components, you know, like the Network Rail components, like the NR60 and all these shallow depth SNCs have been tried and tested for less than 125 miles or below. So I don't know if they will sustain 140 miles per hour. So that's something that you need to look into, yes.
Right, another one from Matt Draper. Has there been any inspection of the Getzner plaids underneath the floating slab track? And do you know how you will replace them when their life expired?
Okay, so yeah, we just started the investigation now because we're discovering a lot of screws broken or missing at a floating track slab. So we're investigating, but I don't think the pads were properly designed because it's direct from the ironwork to the slab track. So, but we're looking at fixing the problem with Robert Sursa and coming out with a design to help with the resilience.
Okay, and the problems of the twin block sleepers on high canted curves, do you have a plan for replacing them or solving that problem?
Okay, so these sleepers are designed for a 40-year design life, but SMCF recently started renewing their LN1, the first high-speed line, and the sleepers all look fine. So they're looking into whether the sleepers can last more than 40 years, so we can use them for 50 or 60 years. So for high-speed one, we will, in the 40-year renewal plans, there's no plan to change all the sleepers, but we would replace sleepers if they are in bad condition. So in high canted track, if they are in poor condition or we really have problems with the truck geometry, we will plan in the replacements.
Okay, thank you. I think I've got to like to call on Jonathan Bray to do our vote of votes.
Okay, thank you, Mike. I'd like to thank you, Sinsin, for an excellent presentation. I've known you for a good few years now, and indeed had the pleasure of working with you on HS1 a few years ago. So this was a nice reminder of, well, some of the amazing statistics of the engineering on the route of its construction and things like the those crossings. I thought it was a good reminder. It's not just a high speed line, but it's a very high performing line as well. Your talk ably showed that, you know, there are plenty of challenges on the routes, quite a few of them there's a unique to HS1 as well. So this is, you know, excellent testament to yourself and the track team on HS1 in terms of maintaining it and delivering that level of performance as well. So I thought that was excellent. So I won't go on any longer. Can I ask everybody maybe to unmute their microphones, and we can either clap or cheer or sing together and show our appreciation and thank Sinsin. So if you'd like to unmute your microphones now, we'll say thank you, Sinsin.
Thank you.
Thank you very much.
Thank you, Sinsin.
Thank you, Sinsin.
Thanks, Sinsin.
Thank you.